Yes, we have another problem about spectrometer, and then it's kind of a logic formulas that we're going to use about the cyclotron formulas. So whoever knows about the formulas, it's going to be easy for him to fix it. So I'm going to give you the results about this problem, and then you can follow up later. So we're going to go with number A. Number A, it's about the nitrogen plus, so we know the nitrogen, the atomic mass unit is 14.0031 unit, and we have to convert this to kilograms so we can have the mass. Because we have two nitrogen atoms, we have to multiply by 2, and multiply by 1.66 times 10 minus 27 kilogram, so we can have the mass in kilogram for the N2 plus. And this one, it will give us 4.65, that power of minus 26 kilogram. This is the first step. The second step, we're going to use the cyclotron formula to find the speed. So the radius is going to equal mass multiplied by the speed divided by the charge divided by the strength field. In this problem, the radius of the entry and the exit, well, the distance is 0.08, so the radius is 0.04. And the mass we just found it is 4.65 multiplied by 10 power of minus 26 kilogram, multiplied by the speed divided by the charge of a proton, that's 1.6 power of minus 19, and the strength field is 0.2. So the speed is equal to 27,526.88 meter second. From here, we can look for the kinetic energy, and that's 1 times half multiplied by mass, speed square. Kinetic energy is equal 1.5. The mass is 4.65 multiplied by 10 power of minus 26 multiplied by the speed, that's 27,526.88 square. So the kinetic energy is going to be equal to 1.76 multiplied by 10 power of minus 17 joules. And the next step to find the potential difference, we're going to use the potential energy is going to equal charge multiplied by the voltage difference. So this one, we're going to use the energy, power of minus 17 joules equal 1.6 times 10 minus 19 multiply, actually this one is volt, not the speed, is volt, multiplied by the volt. So the voltage, that's what we're looking for. The voltage difference is equal 110.1 volt. This is for the first answer for number A. Number B is the same thing, but we have to find the mass of the oxygen. Okay, for the oxygen, we're gonna find the mass of this, the oxygen. There's 2 molecules, so the unit is 15.9949 unit. Well, we have to multiply by 2. Okay, and then from here we're gonna multiply by 1.66 times 10 minus 27 kilogram. So the oxygen is gonna equal, the mass is 5.31 times 10 minus 26 kilogram. From here, we're going to use the formula of the cyclotron, mass multiplied by speed divided by the charge multiplied by the field strength. So 0.04 equal 5.31 times 10 minus 26 multiplied by speed divided by 1.6 power of minus 19 multiplied by 0.2. And the speed is going to be equal to 24,105.46 meter second. And then we're going to use the kinetic energy is equal 1.5. The mass is 5.31 times 10 minus 26 multiply by the speed, that's 24,105.46 square. So the kinetic energy is equal to 1.54 multiplied by 10 minus 17 joule. And then to find the voltage difference, you're going to use the potential energy. So that's 1.54 multiplied by 10 minus 17 equal 1.6 times 10 minus 19 multiplied by volt, and the volt difference is going to be equal to 96.42 volts. Question number C is for the CO2. So the atomic mass unit of C is equal to 12 units, and of oxygen is 15.9949. And we're going to do the 12 unit plus 15.9949 multiplied by 1.66 10 minus 27. So we can find the mass of CO plus. And this one will equal to 4.64 times 10 minus 26 kilogram. And then we use the cyclotron radius, charge speed, so 0.04 times equal mass that 4.64 times 10 minus 26 by speed divided by 1.6 times 10 minus 19 multiplied by 0.2. And the speed is going to be equal to 22586.2 meter second. From here, we're going to use the kinetic energy is going to be equal to 1.76 multiplied by 10 minus 17. And the voltage difference is 110.34 volts.